Okay, so we have a pre-recorded presentation today, and it's going to cut right to the time. So I want to make sure we get started on time. Welcome, everyone. This is the INAD PLAN RT001 development efforts and the INAD rating scale. So today we have Sarah Endemann here to talk about the INAD rating scale and the natural history study done by Retrotope. And they'll also be providing a little overview on the clinical trial study design for the RT001. So without further ado, roll the video.
Hello, thank you for joining today. I'm here to present for Retrotope. My name is Sarah Endemann. I am Retrotope's Manager of Clinical Operations and Patient Relations. I'm joined by my colleague, Dr. Paldeep Atwal, who is a practicing clinical and biochemical geneticist, as well as Senior Director of Medical Affairs for Retrotope. I would like to disclose a conflict of interest, which is that both Dr. Atwal and I are employees of Retrotope, for which we receive financial compensation. Today, we will be talking about Retrotope's first drug candidate, RT001. We will discuss what RT001 is and how it works, our efforts to develop RT001 as a potential treatment for INAD, our work on developing a novel rating scale for INAD, the results of our retrospective natural history study, and the current state of our efforts and future plans. I wanted to clarify that we are here at the invitation of the INAD Cure Foundation. Thank you so much for inviting us to present today. We are not here to promote RT00 in any way. RT001 is an experimental therapy. It is not yet proven to be safe and effective for the treatment of INAD or any other disease, nor is it approved by the U.S. Food and Drug Administration or any regulatory body for the treatment of INAD or any other disease. One of my favorite quotes is, "A worried mother does better research than the FBI." I have found this to be particularly true of myself. And even more so have I found this to be true, not just of moms of children affected by INAD, but of fathers, grandparents, aunts, uncles, and so on. In your odyssey to obtain a diagnosis, to then understand that diagnosis, and search for treatment and cures, you have become de facto scientists. That mindset will serve you greatly today, because in order to understand what RT001 is and how it works, we first have to take a little step back to look at the basic biology and chemistry. All living cells in multicellular organisms have a surrounding cell membrane. You can think of that cell membrane as the protective barrier around the cell that also serves many functions, including regulating which materials can pass in or out of the cells. In normal, healthy circumstances, that cell membrane is an extremely pliable structure composed primarily of two layers of phospholipids. This is called the phospholipid bilayer. You may remember this from high school biology class. And what is a phospholipid? A single phospholipid has a phosphate group on one end called the head, that is the little round circle that you see there, the ball, and two side-by-side fatty acids that make up the lipid tails. Phospholipids can be saturated or unsaturated. If the carbon-to-carbon bonds are all single, that fatty acid is said to be saturated. If the bonds in between the carbons and that fatty acid are double, even just one double molecule, that fatty acid is said to be double bond. That fatty acid is said to be unsaturated. Unsaturated fats are generally liquid at room temperature, for example, oils, whereas saturated fats tend to be solids, such as butter. If there is only one double bond, we call that a monounsaturated fatty acid. And if there is more than one double bond, we'll call that a polyunsaturated fatty acid, or a PUFA. And you'll hear us use that term a lot, PUFAs, because polyunsaturated fatty acids, or PUFAs, provide the basis on which Retrotope's unique drug platform was built. PUFAs are essential components of cell membranes, especially in mitochondria, nerve, heart, and eye cells. But they are an essential nutrient, so we have to get them from dietary sources. Some common sources of PUFAs are things like nut oils, walnut oil, sunflower oil, flaxseed oil, fish oils, corn oil, soybean oil, safflower oil, and all the omega-3 and omega-6 fatty acids. Regardless of what type of oil, PUFAs all share in common that they are vulnerable to oxidation or lipid peroxidation, two interchangeable terms. And what is lipid peroxidation? Lipid peroxidation, quite simply, in a very most basic way, involves taking away a hydrogen from a carbon in a fatty acid chain and replacing that hydrogen with an oxygen molecule, or oxidizing the fatty acid. And this can only occur where carbon-to-carbon double bonds exist, or in PUFAs. Once lipid peroxidation is initiated, a propagation of chain reactions begin, and this continues until we have terminal products produced. This whole process of lipid peroxidation is a chain reaction that stresses and damages cells. We have many mechanisms to help control this. However, in the end, lipid peroxidation can damage the PUFAs by changing their structure and function. The byproducts of lipid peroxidation can damage membrane proteins and change our DNA. And this can lead to cell dysfunction and cell death. And again, this process is happening constantly in our bodies. So of course, in a young, healthy body, we have multiple means to repair the damage from lipid oxidation. So you won't immediately see any great effects. However, with time, the effects can accumulate. And as we age, our ability to clean up the waste products of lipid oxidation diminish. In addition, in certain diseases, we have reduced means to clean up the damage. And the end result of this can be cell degeneration and deterioration and disease. And this is something that happens in many diseases. We know of many orphan diseases that involve lipid peroxidation, lipid oxidative damage. Things like ALS, Friedreich's ataxia, INAD, and those are orphan diseases, more rare diseases. It also happens in many more common diseases, such as Alzheimer's disease, cancers, dementia, MS, and the list goes on and on. Regardless of the cause, Richard Dope has developed a unique approach. And Richard Dope's approach is to replace the hydrogens with deuterium to prevent lipid peroxidation. And what is deuterium? So deuterium is a stable isotope of hydrogen. More commonly in nature, hydrogen will consist of one proton in the nucleus, and it has a mass of 1. An isotope of hydrogen called deuterium will have a proton plus a neutron in the nucleus, and this makes the molecule more stable. So what we have done is that we have taken the hydrogen and replaced that hydrogen with deuterium in the fatty acid. And this renders the lipid molecule invulnerable to oxidation, so that lipid cannot be oxidized. In RT001, we have taken linoleic acid and deuterated it to create a stabilized version, RT001. Our second drug candidate molecule is RT011, which, like RT001, is stabilized with deuterium. It's a stabilized form of DHA. The key is that Richard Dope's drug platform drugs act to prevent the lipid peroxidation caused by aging and disease. Therefore, it is a potential drug candidate for many diseases. But why is this important? Why are we talking about this today? And what matters to you is, how is this relevant to INAD? Well, as you already know, INAD is caused by a mutation in the PLA2G6 gene, which leads to abnormal or impaired expression of the phospholipase A2 enzyme, which is an important housekeeping enzyme. You can think of the PLA2 enzyme as a tiny little vacuum cleaner that sits on the top of those little phospholipid bilayer heads. And under normal circumstances, when lipid peroxidation occurs and oxidized lipids are produced, that little vacuum can vacuum up the damaged lipids. However, in INAD, when the enzyme is not functioning properly, the oxidized phospholipids can accumulate, and this can contribute to neural cell death and dysfunction. When we add RT001, we don't change, repair, or replace the dysfunctional housekeeping enzyme, but rather we prevent the lipid peroxidation from happening in the first place so that there are less or no oxidized lipids to clean up. And it's our hope that by doing this, we can normalize the brain membrane function, the nerve cell function, and slow the rate of neurodegeneration. So what are we doing to bring RT001 forward as a potential candidate for the treatment of INAD? We currently have 2 studies underway. We have the RT001 open label treatment study. This is a clinical trial in which all children receive treatment with RT001. That's the open label component. It's not blinded, it's not randomized. Enrolled subjects undergo observation and testing at baseline, and thereafter they come back every 6 months. We have enrolled 19 subjects in that study to evaluate the long-term efficacy, safety, tolerability, and the pharmacokinetics. In companion to our clinical trial, we are conducting the RT001-009 prospective natural history study. The study is nearly identical to the RT001-008 treatment trial. However, children in this trial do not receive treatment. They are evaluated at baseline and return every 6 months. We enrolled 39 subjects with INAD into this trial and 4 additional subjects with ANAD who are in the study but are not included in our analysis. I have a little diagram here showing the study. Again, the RT001 treatment trial. Patients come in for screening. They have anywhere from 2 weeks to 45 days observation period before we start drug. They come back at day 1, start treatment, and continue on treatment at 6 months, 1 year, and so on. We have now completed this time point for all patients enrolled in the treatment trial. In the RT001-009 prospective natural history study, you will see that the visit schedule looks almost identical. Instead of a screening visit followed by a day 1 visit where patients have an treatment observation period, we just start with day 1. And the children come back at day 180, which is 6 months, day 360, which is 12 months, day 540, day 720, and so on. At each visit, we administer a series of neurological scales in the 008 trial and the 009 study. The one key difference, in addition to not receiving treatment, is that in the 009 study, we do not perform additional neurological testing, such as EEG, NCVs, VERA exams. And with that, I will turn it over to my colleague, Dr. Atwal, who will talk to you about Retrotope's work to develop a unique, a novel rating scale for INAD called the INAD-RS.
Hello, everyone, and thank you, Sarah. So I'll be talking about first on the INAD rating scale. The impetus or the goal of this scale was to reflect the FDA requirements in the roadmap document of patient-focused outcome measures in clinical trials, and to measure how patients feel, function, and survive in a manner that's adequate from the FDA's perspective. If you go to the next slide. So the first thing we did when designing a clinical trial for INAD was to look for an existing clinical outcome assessment or rating scale that would be adequate for to assess any effects of a investigational drug. So you can see a couple of different ones here: the CHOP INTEND, the modified Ashworth spasticity scale, the Hammersmith functional motor scale. All of these were thought to be inadequate for a number of reasons. For example, the CHOP-INTEND, it did not have all of the symptoms that you will see in INAD, ocular symptoms, temporofrontal bulbar, for example. It was designed for a different condition, spinal muscular atrophy type 1. Ashworth, it was a purely measure of spasticity and muscle tone, and doesn't assess the other issues that can happen. And similarly with the Hammersmith, there's not a full assessment, and it was developed for different diseases. So we had to then think of creating an entirely new rating scale that would encompass all of the different signs and symptoms of INAD in a way that we could monitor over time to see if any investigational therapies are having a beneficial effect. Next slide. So the following set of slides is showing some baseline data. So none of this data I'm showing is over time or longitudinal. It's all baseline cross-sectional data on individuals in the trials that were assessed at their initial visit. And what we tried to do with this data was to look at some evidence of usefulness of particular scales. I don't want to get too technical on this, but basically what we found here was it wasn't really the Hammersmith Functional Motor Rating Scale. We couldn't really correlate it with disease progression or how long someone's had their symptoms. And so, as you can see here, the line is flat and it doesn't really correlate. If you go to the next slide, the CHOP-INTEND scale, there was some small weak correlation between the CHOP-INTEND score and the age, the time since symptom onset. But again, not strong enough for us to feel comfortable using it as a primary endpoint. The modified Ashworth spasticity scale did have a stronger correlation, and interestingly, it fits with the natural history of the condition. The longer time with symptoms results in increased spasticity, suggesting that spasticity is progressive in nature, which is in keeping with the natural history of INAD. So that certainly at the stage when we saw this, we thought it would be have some use as a clinically meaningful endpoint in a clinical trial in INAD. Next slide. So we also developed a new rating scale called the INAD rating scale, INAD-RS, encompassing 6 domains with a total score of 80. All of these domains represent symptomatology in INAD: gross motor, fine motor, bulbar function, ocular, temporofrontal, and autonomic. And each score has a 0, 1, 2 rating, higher score meaning better performance in that rating. And if a patient cannot perform the test, they would have to get a 0 score for that. Next slide. Briefly, a number of different individuals were consulted to varying depths of questioning and comment on INAD and the rating scale, as well as many parents and caregivers. You can see a list here. Next slide. So the INAD neurological score, we looked at a number of different factors. The months since they've had the condition, the age in months at the time of the assessment, and then the genetic variant, whether there's what's called a point variant or a single nucleotide pathogenic variation, or a truncating variant, deletion, or a premature stop. So what we found was a strong correlation between how long the individuals have had INAD and also the actual age of the patient. So next slide. We compiled all of the data, preliminary data, and published it in a paper describing the rating scale. And that was published, you can see here, the abstract in 2020 in the Orphanet Journal of Rare Diseases. And we basically, our goal with this was to show that we've developed a scale that could potentially be used as a clinically meaningful endpoint in INAD. Some more baseline data here. We looked at cross-section of some of the early enrolled patients in the open label trial and the natural history trial. One, to ensure that they were similar in their presentations, and two, to see what kind of progression we were seeing on the, what kind of curves we would expect to see if we followed them. This is obviously all baseline data, so we don't have anything on progression. And you can see there's fairly reasonable trends here of the longer they have the child has the symptoms, the worse their score. Next slide. This is just all of the pooled data, and you can see that the R squared measure of correlation is 0.54, which represents a reasonable correlation. Next slide. Switching to a different condition, ALS. There's some initial data of open label, of expanded access patients who have been treated with RT001, and you can see there the ALS functional rating scale decline with RT001 compared to placebo and Radicava. So it in this small cohort, it appears to lessen the decline compared to placebo. Further studies in this area are being discussed. Next slide. Another different condition known as PSP, or progressive supranuclear palsy. These are data on 3 individuals with RT001, and you can see a signal of improvement in their rating scales, PSP-RS and UPDRS. Again, a formal PSP trial is currently ongoing in this condition with RT001. Next slide. So next I'm going to talk about a retrospective study that was completed as well as the INAD scale development. Next slide. So the retrospective natural history paper was published and comprehensively analyzed the charts of 28 patients with INAD from across the world, from the Middle East, from North, South America, and Europe, all molecularly or genetically confirmed to have INAD. The common clinical findings were nystagmus, seizures, gastrointestinal issues, skeletal issues, and strabismus. Common consistent biomarkers, cerebral atrophy, and elevations in the AST liver enzyme and LDH levels. In this particular cohort, truncating genetic changes, so missense, truncating, so not non-missense or in frame were found to be different in terms of the time of initial presentation, generally more severe than only the presence of missense or in-frame deletions. There was no difference observed based on ethnicity in this cohort. Next slide. Here's the abstract of the paper, and it's one of the largest studies done on the natural history of INAD. And it was a multi-center effort. This is one of the images from one of the figures from the study, which shows the yellow box represents the mean age at which each milestone in the blue box is lost. For example, balance appears to typically be lost at 16.5 months, language and the top right at 27.5, and so on. And next slide. And then this shows this chart shows the frequency of clinical manifestations. You can see the spasticity and nystagmus are the most common, whereas reflux and kind of a generalized low tone seems to be the least common feature. The next slide. This slide shows the age at initial loss of milestones by variant type. The more severe genetic changes seem to result in earlier onset of loss of that particular milestone, whether it's the initial concern, the initial loss of language, the initial loss of fine motor skills. Next slide. So where are we now and the future plans? So I'll just briefly go over that. Next slide. So in the RT00108 open label clinical trial, all of the 1-year visits are completed. 12 patients remain on the optional open label extension. The mean follow-up is around 20 months. And in the prospective natural history trial, there have been around 30 that have completed the 1-year assessment. Go to the next slide. The endpoints that have been submitted, and we're waiting FDA feedback on the analysis plan, is a composite endpoint of the rating scale, INAD rating scale, and the modified Ashworth scale. The rating scale has gone through some modification based on parent-caregiver feedback and disease experts as well. So it's now known as the modified INAD rating scale. There's also been statistical work done through psychometric analysis and rash analysis to further refine the scale. And that work is ongoing. If you go to the next slide. The plan for that is highlighted here. Some of this is completed, some of this is ongoing. And the goal is to complete it, get the FDA's feedback on an agreement on a statistical analysis plan of the endpoints, and then unblind the data and see if there's any effect of RT001 on INAD. Next slide. Thank you very much for listening. If you have any further inquiries after the conference, please contact Sarah Enderman here, and this is her email, sarah@retrotop.com.